Hello guys and good evening. I really apologize for not doing this earlier. My week has been quite packed, so I'm trying to do a snappy walkthrough and share it to provide assistance to those struggling. So let me just move straight into it. We are not going to connect anything with the SQL database, so we use this MD Water Services database. I have already worked on it, so for this walkthrough, I'm using the copy, the one I have renamed it as copy. So let me create a file and then import it. Then we can start running. Okay. So let me come back to my Power BI import data. Yeah, so I'm using the copy version here and then open. So once it's downloading, I'll check all the tables or the worksheets in the workbook, and then once everything is done, I can load it. Okay. So I'll also wait for a while whilst it loads. Still loading. Okay. It's taking longer than expected, but I hope it. Wow. Okay, so I think it's done now. We have all the tables here. So let's take a look at the model view to see how everything looks like. Let me minimize this and then minimize. Let me squeeze my screen a bit. Too small. Okay, so let me rearrange everything to see if everything looks as expected. So water source, okay. Project progress. Let me bring this here. Okay, so visits, come here. Water source, come here. Pollution should also come here. Project progress. So I'm trying to align everything so it becomes a bit easier on the eye. Right. So comparing this to what we are seeing here, it doesn't really look the same. Okay. So let's move on and see what we can do for the infrastructure cost and then the location. So it says if you do a quick scan of the module, you should notice several one-to-one and one-to-many relationships along with directional indicators for each of these connectors. So we can see one-to-one, one-to-one, many-to-one, one-to-one, one-to-one, and then the directional, indicators. So have a closer look at visits. Remember from SQL, we used a similar table quite often to join tables together because it was a bridge table. Two of our tables are in the module, but they are not correctly imported and the relations are not established, or the relationship is incorrect. In order to use the data in those tables, we have to fix this first. Let's start with the location. The first issue is that none of the column names or headers were imported correctly. So open up Power Query Editor and fix that. As soon as you do this, location should update its relations automatically. So this is the location, and we can see column 1 to column 5 here, which is not supposed to be, right? So let's open Power Query Editor here. And then let's select the location table. Then, as we can see, we have column 1 to column 5 here, so we are going to update this. So we'll just use first row as headers, and then once that is done, we can close and apply, and then let's wait for a while. Good. Once it's updated, we see that the relationship has been created. There is this infrastructure cost. It wasn't touched on here, right? Because looking at looking at this picture we have here, infrastructure cost is linked to the project progress table. But coming up here, we find out that it's standing on its own. This is project progress, and infrastructure cost is standing on its own, right? So this is what I did with it. First off, let me open the Power Query editor and select the infrastructure cost. What we can see here is that we have a lot of null values under here. So it means all these, what's the name? The table contains these cells which have spaces in them, or maybe it wasn't saved well, right? So what I am going to do is I'm only going to edit it to remove the null values in there, right? So I'll go to remove rows, yeah, and simply remove duplicate, or sorry, remove blank rows here. Once that is done, we are good. Okay, so I'll close and apply, come back here, and then create a relationship. Okay, I'm going to create a relationship, a new one. So the relationship is between the project progress and the infrastructure cost with the link on improvements. You realize they connected instantly, and then okay. So once I click on close, we should have a relationship between the infrastructure cost and the project progress. So we've been able to fix that. So let's go on. So next step, check out queue composition. You can fix that problem by removing column 1 from the module. It was identifying column from Sana's data that we do not need. So queue composition. So again, let's go back to the Power Query editor. For queue composition, it says we should remove the first column because it was not needed. So we just click on that and then we'll click on remove columns. Then that should be it, right? So close and apply. Then the next thing here is, oh, sorry. Finally, we need to connect water source related crime to the rest of our module. So first, remove column 1 from the table, the water source related crime. We should remove column 1 from the table, this one here, right? So let's transform. Go to related crime and then click on the column you want to remove and click on remove columns. Close and apply, and we are done. Right. Now here's the challenge. Power BI doesn't recognize the location ID. Power BI doesn't recognize that location ID is related to location ID columns because this is loc ID is related to location ID columns because the name is not exactly the same. But the question is, which table do we connect it to? Let's take the tech way and just try. So open up the relationship manager and link water source related crime to visits using location ID or loc ID. If you try, Power BI wants you that there is a many-to-many relationship. As you may have seen, many-to-many relationship often cause problems with filtering, so we should avoid this. So let's open a relationship manager and then we'll link water source related crime to visit using location ID, right? So let me open manage relationship, new. So water source related crime to visit using loc ID and location ID here. So it says it's a many-to-many. Now let's come back here. So let's unpack the problem a little. Water source related crime contains crimes over the last 10 years that happened either at or near the water source location ID. More than one crime should have been committed at a specific location, so loc ID is not unique. Similarly, visits have multiple visits to some locations, so location ID is not unique either. This is why there is a many-to-many relationship here. Power BI cannot connect location IDs because it cannot figure out which duplicated location ID in visits is linked to a loc ID in water source related crime. So how do we solve this? We have two options. One is to create a bridging table that will have unique location IDs linking to visits, or in our case, we are lucky because one of our tables already has a unique set of location IDs, right? So go sniffing around a bit and figure out which table has a unique set of location IDs and link water source related crime to that, to the data model. So what is trying to say that, let me close this first. Because we're trying to connect the water source related to the visit using location ID and lock ID, these cannot really identify them. So it's creating a many-to-many relationship here, right? But then we've been told that one data in here contains the same location ID as water source related ID. So we should sniff through and see, sniff around and see which one can be, okay? So I'll just go straight to the point, and it's a location table, right? Location table contains the unique location IDs in here, right? So let me just create the relationship for water source related crime and location. Then I'm going to join location ID, unlock ID. Then we get our minute one relationship. So we're good with that, right? Once I close it, the relationship should be created. Then we now have the links between all our data sets. Next up, let's look at relationship. Many of the relationships in our data model have bidirectional filtering, but most of them are one-to-one relationship, which is perfectly fine. Remember that one-to-many relationship with bidirectional filtering can cause problems. So it is best to start off with as many one-directional filters as possible. And if we run into an issue, we will change it. So make sure that all one-to-many relationships have single directional filtering enabled. So one-to-many relationships. We can see one-to-many relationship here. It has a single directional, so this is okay. One-to-one has a bidirectional, so, and then many-to-one single, many-to-one single, one-to-one, many-to-one single. So yes, everything is okay. Okay, now we need to make sure all of the data is loaded as we expected in the tables. Numbered columns are loaded as numbers, etc. Spend a couple of minutes going through the tables in the table view tab to make sure the data is correct. So because we did a lot of work to clean up the data in SQL, our data looks ready to go back. Let's just spend some few minutes to go through, okay? So in the table view, should I use this? Yes, I can use this. So for infrastructure cost, for improvement, we can see everything here is text and data type is text. So it's good. Unit cost, we can see numbers here and this whole number. I don't know if we should change it. There's nothing accounting here. So whole number should do. So we are done with infrastructure cost. Let's look at location. So we have location ID as text. It's good. Address text. Province name also text. Town name text. And then location type also text. So location looks good. Project progress. So project ID is a number, whole number. Source ID is text. Address also text. Combination of text and number, so text is ideal. Town is text. Province is also text. Source type text. Improvement is also text. Source status text, and then date of completion is text here. Comment is also text, but in my case, I tried to change the date of completion because it's date. I changed it to a date timestamp so that maybe, I don't know if in future we are going to update it or do anything there. It's easily identified, right? So I only changed date of completion to date timestamp. Okay. So let me now move from project progress to queue composition. We have record ID as whole number. Percentage mil is a decimal because it can be more than 20 point something percent. Percentage female also decimal, and then percentage child also decimal. That is okay. It's formatted as a decimal, so it doesn't matter. We can still maintain here decimal number, or we can leave it as general since the data type is already the decimal number. It's fine. Visits. For visits, we have record ID as a whole number, location ID text, source ID text, time of record is a date and timestamp, visits count as a whole number, time in queue also a whole number, assign employee ID a whole number, right? Water source, we have source ID as a text, type of water source as text, and the number of people served as a whole number. So it's good. I think everything is okay. So but let's just be sure. Okay. Water source related crime ID is text. Time of incidence is also the timestamp. Location ID text. Crime type text. Victim gender also text. Water source related crime is okay. And then well pollution. So we have source ID as text. Date is a date timestamp. Description text. Pollutants, there's also a decimal number. There's a percentage. Biological is also a decimal number, also a percentage. End results are text. So everything is okay here. You can then go back. Now let's pause a second and unpack the module a bit before we go to visuals. Ideally, we want a fact table with details about those facts in various dimension tables. Visit is our fact table because it's recorded thousands of inspections of water sources across Maji Ndogo. Location has details about where the visit happened. Water sources has details about what they found at those locations. Water pollution has more details about some of the resources. Q composition has data related to who we saw. Q when we visited the location. But tables like project progress and water source related crime have nothing to do with visits. These are fact tables on their own. Star schemas in Power BI makes filtering and drilling simple. So we always aim for that. But that comes at a cost. All of the data has to be the same all of the data has to be at the same granularity granularity so that the relationships are one-to-one or one-to-many. In our case, we have more than one fact table with data describing different things. Water source related crime links crime from the past 10 years to a source location, which is unrelated to visits. This complex relationship prevents us from making a simple star schema. So we can see that we don't have a simple star schema because water source related crimes doesn't have anything to do with the visit, as well as the project progress, right? Assuming project progress and water source related crime were linked up to visits, everything in here would have been linked up to visits. That gives us a star schema. But since water source related crime and project progress are a facts table on their own, we are not having that here. So we could describe our model as a multi-star schema. This is common when we connect data from different parts of our businesses. Connecting data that isn't directly related can help us get deeper insight into our data, but it comes at the cost of efficiency. So why did we just do all of this? Well, now our data model is in good shape to help us visualize data effectively in Power BI. So let's rebuild the visuals we need for the report. So let's go to our reports view. Then the first thing is to create a national page and add the following visuals. So let me rename this to national. So we are going to create the map of provinces in Maji Ndogo. I think we already remember this because we did it in the previous projects. So I'll first begin with the shape map. Then I can select the location since was it map of provinces. So location, we'll select province name. Let me drag it to the location part. Then I'll go to map settings. I'll change the settings to custom map. And then I'll browse the map. And then I'll select MD provinces.json. Now we have this here. Just go to general, and then I'm going to remove the background effects. Then we are done. Right. So we are done, but we are not done. After doing this, the next thing we did was to insert an image, the MD map. So once we are done with this, let's format it and send the image to back. Put it on top. Try, play around with it to, fit directly on the map. This takes a little bit of time. Let me just be snappy about it. So we can move on. Hope this helps a little bit. I'm not going to spend much time on here. Yeah, I think this is okay. So you can move on. So we are done with the map. And the second is a pie or donut chart of population split between urban and rural. Okay, so I'll use a pie chart, and then population split between urban and rural. So where are you location type can fit. So we have rural and urban, and then we realize that from the previous one that we did, the previous projects that we did, in doing that way, we used the population, sorry, the location type, and let me get that right. Was it the number of, I think the total number of people served? Where can we get that one? Let me see. No, should be somewhere. No, not here. Not here. Visits. Why am I not getting this? Let me see if this will work. Number of people served. No, this doesn't work. So let me try and see. Let me see water source. Okay, so there's a challenge, there's a little challenge here. Let me try and deal with it here. So let me open the water source table, and we have number of people served here. Okay, it is a whole number, but it has been stated that we shouldn't summarize it. So I'm going to change this function to summarize. Okay, once I summarize it, then we can now aggregate it to be able to get what we want. Okay, so we realize that from the previous project, there was a total number of people served. That will help us identify which one is from the rural and which one is from the urban. So I'll grab this here to the visuals. And then we did a filter, right? So we set visit count to 1. Sorry. So advanced filtering. So visit count is 1 here. Let me apply. Okay. Something is not right. Oh, something is not right. Something is not right. Let me see. So yeah. It wasn't average. It was, oh, sorry. There was some moment. Okay. Let me try one thing again. So let me put the visit count on the entire page. So visit count is 1. Apply filter. Still not working. Why this challenge? So number of people said by location type 28. No, they are not 28. Taking out duplicates. Okay. Let me go on and see something. So remember to set the appropriate filter versus count. Yes, is 1. And choose provinces from towns and location. Yes, done. Try to use town from project progress. Also remember that rural is a town. So okay, we've not gotten there yet. Pie and donut chart of a population split between urban and rural. Urban and rural population. So why am I getting a 50-50? Oh, come on, come on, come on, come on. 28 million, yeah. Location type. But yeah, not 50-50. Oh, oh, hey, province name. I don't need province name. I don't need town name. It's location type. Okay, let me see. Let me see. Uh, Number of people served. Is it some? Does it count as one? Okay, let me just move on. I'll attend to it later on. So a tree map of the total number of people served per source type. So where's the tree map? There you are. So total number of people served per source type. So again, the total number of people served is this. And then where's the source type? Water source. So type of water source. Yeah. Okay, so we are done with that one. And then a column chart showing the total number of each source of type of water from every town. So a column chart. This is that. No, let me use this. No, let me use. Oh, okay. So we start column chart showing the total number of each source of type of water. So um type of water should be on the x-axis, and then total number. So y-axis will be total. Then let me bring this on the legend. Um, okay. Okay. And then the next one is column charts that counts the different sources by type. So a column chart that counts the different sources by type. So let me use this again. So it counts, I'll put it both on X and Y. Okay, the fourth one is in column chart showing the total number of each source of water type for every town. So for this one, we need to include the town name. So um this won't be here. So where's the town name? Oh wait, this looks a lot. Let's see this. Okay, and then let me put this here as well. Okay. Remember to set appropriate filter for visit counts to 1. Okay, it's already done. Choose provinces and town from location. Try to use from projects. Also remember that rural is a town in our data sets. So for 3, we need to remove rural from the data. Okay, so this where are you? Town name. Said I should take rural out. Roll, are you? So roll it out. Okay. And then for this, let me see. Town name. Does not contain roll. Let me apply filter and see what happens. Okay. So let me see something here. Oh, this is how it's supposed to look like. So type of water source. Okay, this we have here. And then type of water source by town name and type of water source. So okay, so easy. So town name. Where are you? Okay. Then type of water source. Need a let me use this. Good. So count of type of water source by town name and type of water source. So it says count. Where are you? Okay. So I need to do one or two changes. The town name does not contain rural. Yes, it's out. Now I need to work on this and this. So first, let me deal with this. So let me. Oh, okay. So my water source is short and low. This is a problem with one of our filters. The location and source tables are linked by lines. Oh, okay. But the arrow beneath water source and visit points towards visit. This means the filter can only work in that direction. When we create a visual type that has type of water source as a value and we want to split up that data by per province, the filter has to come from location to visits. So the fix, we allow filters to pass both directions. So let's change the directionality. So between visits, water source, and then okay. So where's visits and water source? So let's change this cardinality. Sorry, the directionality. So let's change it to both. And I think once that is done, we should have so here we have it. So we now have this, and that was the same thing that was dealing with it. So both of them have been corrected here. So we now have this. I'm not going to touch this. Let me increase this a little bit. Easy. Do some little adjustments here and there. Okay. Then okay. So I think we now have our first, and I'm sure pretty much looks exactly like this. You can try and change our theme a little bit. Which one should we use? This should be okay. Yeah, it's quite darker. Okay, so let me go on. Right. So once we clean it up a bit, so this is what they got. Maybe we can spend time to clean. No, this visualization window. This theme won't do. So let me change it again. Yeah, this should be okay. So it was renamed. This was renamed to population here. All of them were renamed. So let me try and work on some of them. But then for time factor, I won't go through all of them. So I'll go to the formats general. I'll change the title to this one was for population. So there I have it. Then where are you? We have a lot of things were done, but if I should go through them one after the other, time will not be on our side. Okay. So basically this is how it's supposed to look. I think maybe one final thing that I can do is for um the data labels. I'll turn data labels on for here so that we'll be able to see the values as we are seeing them on here, right? Then let me take off the y-axis, values, so it becomes a bit easier, right? So that's the only thing I'm going to do. And one other thing, I am going to leave this as it is because over here we are seeing 10.9K and over here we're seeing 17. There's a reason behind it. If I should filter rural out, we'll have our 10.9K, right? And if I should do urban, 10.9K, 3.2, 2.9, as we are seeing here, okay? So share tab is 4.3, and then in that order, right? But I'll leave it as it is for a reason. Hopefully I'll be able to explain that um, as we go along. So, okay, now let's explore what we can do on this page. With nothing selected, all of the metrics we show at the national level. When we select one of the provinces on the map, the location type, people served, and water sources all filter. So when we select one of the provinces on the map, so let me select any of them, it filters it out, and that is what we expect. Okay, so when a decision maker looks at this page, they can look at the specific provinces and see all of the different results in the context of the national data. The tree map shows us how many people use the water source per type of source, but its functionality is actually to select each source type similarly to the function of the map. Filtering the sources can help engineers who are responsible for share types, for example, to see what they need to do nationally, provincially, rurally, and in each town. Cool, right? We are going to keep on working on this later. So I'm going to create a page where we can focus on queues and copy the map to this page. Okay, so I'll create a new page. I'll call that queues. QE. So queue. I'm told to copy map here. So I'll click here. Remember, there are two visuals. I'll click on the first one. Let me do that again. So I'm going to click on the first one, hold Control, and then click on the image beneath, copy with Control C, go to Q, and just paste it with Control V, and that works. Oh, sorry. Don't select both. Don't select both. Take your time. Right. Okay. Now to Q. Let me do that again. So I'll select this and then hold Control, select the second one, copy, go to Q, and then just paste. Hey, why are you not pasting? Uh, I'm trying that one more time. So I'll select this and then select the second one, copy, come to Q, paste. This thing is giving me tough time. There's not much time. So okay, let me copy this, paste it here. Do something else. What is this? Oh, let's copy and paste too. Selected the first one, hold Control, select the second one, copy, Control C, Q, paste. Not working. Okay, I'll do it the hard way. Let me close this. Let me delete this page. Is there something wrong with this thing? Let me duplicate this page. Good. Rename it to Q. Trying to delete this, but it's not going anywhere. Delete. Okay. Let me rename it to a new page. And then over here, I'll just delete everything in here and only leave the map. We don't have much time. I don't know why this thing keeps playing tricks on me. Okay, so we have the map here now. Okay, so now I think we can move along. The visuals we want to include here are the ones related to queue times. If you try one, you're going to run into a problem. In the table we used last time, I calculated the hour of the day and the day of the week for you, but now we have a timestamp. If you use that in the queue time for the days of the week, it gives us the option to look at the data per year. Per year, month, and day, but we need something different. Head back to the data model. We need to extract some information into new columns. I know you've never done this before, but I'll show you how to do it. So open Power Query Editor, select Visits Table, select Time of Record column, select Add column on tab on the ribbon at the top, then dates drop down menu, navigate day, select day of time. So this is what we're going to do. We'll just come here and then table view. I think there is something fundamentally wrong with this thing. Let me save this. I don't want to lose anything that I am doing. Please spare me a minute. This thing is taking longer than expected. Save. Hey, nothing seems to work. Control S. I wouldn't want to go through this all over again. Guys, kindly give me a moment. Let me try something.